how we are moving from source A to destination C by the help of the intermediate tower called C. What is the depth of recursion? How many times the recursive function calling itself is called as a depth of recursive function. If you generate infinite sequence, it's not possible for the compiler to come out of the recursive function. It keep on executing the same thing. Hello everyone, welcome to one more session on data structure. Here we are continuing the discussion of Introduction to the Data Structure, that is Unit 1. We are dealing with the session 3 for B.Ca student. Myself, Induje, the Faculty of Computer Science Department, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. Let's start today's session. As we have discussed in the last session, about recursion, what is recursion, how recursive function is called, how recursive function is defined, and we have seen two examples how to calculate the factorial and how to calculate the GCD using the recursive function. Today we are going to discuss one more example of recursive function, and we are going to discuss the properties of recursion and differences between iteration and recursion. Then we have arrays. We're going to discuss arrays, what are the different types of arrays we have, and then we have array as an abstract data type. That's all we are going to discuss in today's session. So let's move on with the topic. Tower of Hanoi. What is Tower of Hanoi? It's a puzzle game. I hope all of you love the game. Okay. What is Tower of Hanoi? We have 3 towers. Out of 3 towers, we have 3 disks or n number of disks, we can say. N number of disks from tower A to tower C. We have to shift the n number of disks. How we have to shift? There are set of rules. If you are playing any game, obviously the game has a set of its own rules. Similarly, Tower of Hanoi has also set of rules. Let's see what are those things. What is Tower of Hanoi? Tower of Hanoi is a mathematical puzzle. Mathematical puzzle where we have 3 rods. Say 3 towers. Tower A, Tower B and Tower C. Okay. Out of these tower, we have n number of disks. Say, consider there is n number of disks, so on. In this n number of disks are stacked in decreasing value. Like we have bigger on the base, then little more smaller, then smaller, like that. Will be stacked in the descending order in the tower. The smallest disk is placed on the top on the rod A. On the rod A, smallest disk is placed on top. The objective of the puzzle is to move entire stack to another rod. This complete entire stack has to be moved to another rod, that is destination rod. We say it as C. By obeying follow simple rules. As we say game, it should follow some rules. Let's see what are the rules. Only one disk can be moved at the time. Only one disk can be moved at the time. Each consistency of upper disk from one of the stack and placing on the top of the other. We can place one disk on the top of the other, but what is the condition? There should not be a smaller disk, should not be at the bottom. We cannot place it like this. This is a smaller disk. Above that, we cannot place the larger disk. This is a wrong way of placing a disk. So whenever placing, the larger disk should be at the bottom and the smaller disk should be at the top. Like that only we have to place. This is a set of rules to play the puzzle. So what is the idea how we can move from source rod to the destination or source tower to the destination tower? Idea is to use a helper node to reach the destination using the recursion. What is this tower A? Tower A is a source and tower B, we have tower C. Tower C is a destination. What is this? It is an intermediate state. intermediate rod. How we are moving from source A to destination C? By the help of the intermediate tower called C. The pattern how we are moving is that shift n minus 1 disk from A to B. What we are doing, we are not moving this last rod. This is nth rod. This is different number of rod. We have to move all this n minus 1 rod to the intermediate disk B. Then shift the last disk from A to C. This last disk has to be shifted to C. Okay, now A will be having no disk, B will be having n minus 1 disk, B will be having n minus 1 disk, and C will be having n disk. After that, what we have to do? Shift n minus 1 rod which is there at the tower B to C using A as an intermediate rod or intermediate tower. Now, after this first step, A will be not having anything, B will be having n minus 1 disk, and C will be having n disk. Now, this A disk is completely free. So, this whatever the disk is there in n minus 1, that has to be moved to C with the help of A. That is only 3 steps what we have. But these 3 steps has to be executed on recursion basis. Let's see how it will be done. So, here we have taken a number of disks, that is n value is equal to 3. Number of disk, how many disks we have? N value is equal to 3, and number of rod or number of tower will always be 3. Okay, rather how many number of disks are there? The number of towers will be 3 only. So, this is a initial state. Okay, this is a initial state. Now, I have to move this complete n minus 1 to B. How I am doing? First, we are switching, say this is 3, 2 and 1. This is a disk number which is in a green, that is 3, which is in a white 2 and in orange 1. Okay, we will name the disk for easy understanding. Now, I will move this particular disk 1 to the tower C. Okay. Then after that, I'll move this disk 2 to tower B. Disk 1 and disk 2. Now, what I am doing? This we have to transfer disk 3 to C. Before we have what? Disk 1, which is a smaller than 3. So, before that, what we have to do? We have to transfer that to the B. There now, B will be having n minus 1 disk, that is 3. N minus 1 disk, that is 2 disk B will be having. Now, C is empty. So, what I am doing? I am transferring this n disk to C. Okay. This is our step number 1 and this is our step number 2. Okay. Next, after this, what we have to do? Our step number 3, transfer n minus 1 disk which is there in B to C with the help of A. Right. So, this is n minus 1 disk what we have. Right. We have to transfer this from B to C using A. So, what I am supposed to do? A is empty. So, transfer this particular disk 1 to A, transferring disk 1 to A and transferring disk 2 to B. Yes, this 2 to B. Then after this, transferring disk 1 to C. This is a third step. Okay, clear how Tower of Hanoi will work. If it is a larger number, if n value is equal to 10, how many recursion it may need? It may need lot of steps to compute this thing. So, we are using the recursive function to reduce the number of steps. Tower of Hanoi algorithm what we have, follow the steps below to solve the problem. This is a algorithm for solving the puzzle of Tower of Hanoi. Create a function Tower of Hanoi where pass the n value, n is number of disk from which rod to which road? From where we are passing? From A to C using B. Right. What we are doing? We are transferring n number of disks from tower A to tower C using B. Okay, that is a first thing. Make a function call for n minus 1 disk. What we are writing? We are writing one function called tower of Hanoi. For this tower of Hanoi, we are making n minus 1 call for disk. Then print the current disk along with from and to. Current means what I have left with? If n minus 1 is done, I have left with n from A to C. That is what we are printing. Again, make the function call for n minus 1. Where we have n minus 1 will be having in the rod B. For this rod B, we have to make again function call Tower of Hanoi. This is a algorithm what we have to solve the Tower of Hanoi problem. Then efficiency of recursive function. What you meant by efficiency of recursive function? As we have dealt with the efficiency of algorithm in the last session, we are looking into the efficiency of recursive function. How we are computing the efficiency of recursive function? It depends on the depth of recursion. What is the depth of recursion? How many times the recursive function calling itself is called as a depth of recursive function. The depth of recursive function is a number of times. How many times? Number of times the function is called recursively. Okay, that is nothing but depth. As the depth of recursive function increases, the memory required to store the recursive function values will be large. So, it basically depends on the depth of recursion. If the depth of recursion is less, it can execute efficiently in the fast manner and consumes less memory in the space. As the depth of recursion increases, the program has a large number of recursive calls. We may run out of the memory. As depth increases, how many number of times recursive function call itself, those many memory block has to be allocated for the recursive function. So, it's saying that we may run out of the memory. So, it is the efficiency of the recursion is greater if depth of function is less. We can state this: efficiency of the recursive function is greater if the depth of recursive function is less. So, that's what about efficiency of the recursive function. So, what is the advantage of using the recursive function? The advantage of using the recursive function is clear and simpler version of recursive function. We need not to break our heads to write a number of codes. It will call the function itself and it will execute itself. Clear and simpler version of recursive function can be created. Recursive function definition can easily be translated to the recursive function. Whatever we are defining it as a recursion, and we can translate that into the function very easily. Many functions are easier to implement using the recursive function very efficiently. For some of the problems or what we are solving it for can be used efficiently, like what we have done, Tower of Hanoi and GCD, finding the factorials, finding the Fibonacci series. These are all some of the example where recursion works very well. Okay, it purely depends on what type of problem you are solving. Next topic what we have is disadvantage of recursion. Right, as we just discussed in the efficiency, as number of steps goes, the depth of recursive function is large, it will consume large memory. So, it will consume lot of memory. That is a major disadvantage what we have in a recursion. Consumes more time to compute. As we have number of steps to be computed, it consumes large number of time. They often execute slowly because of the overhead of represented function call. As function calls itself many times, there will be an overhead. So these are three major disadvantages what we have in the recursion. One is it consumes lot of memory, it takes more time to execute, and it may lead to the overhead. So these are all three major disadvantages what we have in the recursion. Next, we'll look into the property of recursion. What is the property of the recursion? The recursive function should never generate the infinite sequence call. We have discussed it already. When we are discussing with the base case and the general case, we have discussed it should not generate infinite sequence. If you generate infinite sequence, it's not possible for the compiler to come out of the recursive function. It keep on executing the same thing. An algorithm exhibit this sequence of the call will never be terminated. If it is an infinite state, it will never be terminated. Then there should be at least one base case. To terminate the recursive function and to make it should not enter into the infinite sequence, one base case, at least there should be one base case, right? One condition to come out of the recursion. This condition does not exist, no recursive function can never be computed. Without the base case, you cannot compute the recursive function. It will keep on executing itself. You don't get the result only. You don't get the output. That is the thing. The base case is very important when we are defining the recursive functions. So let's see what is the difference between the recursion and the iteration. What is iteration? Iteration executing the program or the instruction one by one. That is called as iteration, and you know what is recursion, right? So based on the following control structures, which all control structure we are using in the iteration is, we are using the loop, repetition structures such as while, do while and for loop. We are using conditional loops here to execute the functions. More than one. What are those conditional loops? That is for loop, while loop and do while loop. Here we are using only conditional statements like if else and switch statements. Okay, iteration explicitly uses the repetition structures. It will be using repetition structures such as given above, and a recursion achieves the repetition by calling itself, by calling the same functions. Then terminal condition. If the looping condition fails in the iteration method, it terminates, it come out of the loop. Here it is mandatory to have a base case to terminate the recursion. Next, what we have is, this occurs if the condition never fails. What occurs? Infinite loop will occur if the control conditions or control loop does not ends. Or here, if you don't have a base case, it will enter into the infinite loop. It takes more time to execute and more error prone. Recursive functions are more efficient, can be understood very easily. As we don't have much number of lines of code, we can easily understand and we can easily design. Iterative functions execute much faster and occupy less space and can be designed easily. As we are going from sequence of order to execute, it is less memory consuming, less time consuming. As we are dealing with the depth of recursion, it is more time consuming and it will have more memory also. So this is all about the difference between iteration procedure and then the recursion procedure. Next, we'll move on to one more topic, that is called array. You have studied array. What is array in C? Array is, as we have done in the first session, array is one of the non-primitive data structure that is derived from the primitive data structure. What is primitive data structure? That already exists. Non-primitive data structure is what? Using these existing data structures, we are designing one more new data structure, that is called as non-primitive data structure. Array is one of the example and majorly used non-primitive data structure. Okay, the array is one of the linear data structure where the elements of the same data types are stored one after the other. Linear means obviously it will be stored one after the other. This is a representation of array what we have. Or you can give one more definition for the array. An array can be defined as a ordered list of homogeneous data element. What do you mean by homogeneous data element? As we have a primitive data type int, float and characters. If I want to create an array cannot have combination of these data types. It can have only the integer array, only the floating point array and only the character array. Okay, that is called as collection of homogeneous, similar type of data. Homogeneous element. These data elements may be types like integer, float, character or double. How do we declare array? To declare array, we need to specify which data type it is belonging to, whether it is an integer, floating or character. Then we should give one name for that particular array as a variable. Then we have to give the size for that particular variable. How many elements we want to store? That is nothing but the size. Next, an array describes a single name or an identifier. You want to store 10 values of the integer. For example, you can take one student will be having 7 subjects, right? I want to display the 7 subject marks of the particular student. So I need to have one particular variable that can hold all the 7 values. That is a single name or an identifier. Each individual data item in an array is referred by the subscript. Individual data items will be referred by the subscript called as index. Index, how we are providing? 0, 1, 2, 3, 4 and 5. So what is index? Index always starts with 0 and end with n minus 1 time or n minus 1 value. This subscript indicates the position of the individual data item in an array, and subscript must be used as unsigned positive integer. Unsigned positive integer. We are not allowed to use a negative value when we are giving the indexing or a subscript. Okay, this is how we represent. What is this? This is a name of the array. Salary is name of array. And this is a size of array. This is a size of array. Okay, next we are moving into the types of array. How many types of array we have? We have 3 types of array: one-dimensional array, two-dimensional array and multi-dimensional array, called as 1D, 2D and ND. Okay, let's see what is one-dimensional array. One-dimensional array, as we have represented, it will be stored linearly and moving towards one direction. That is called as one dimension. It is a list of items that has one value variable and one subscript to access the item. Okay, that is one dimensional. It is similar to the row matrix or column matrix. You can represent the array like this, or we can represent the array like this. It can be the row matrix or it can be column matrix. Okay, so it is also called as a single dimensional array or one subscripted array. Why one subscript? Single dimensional matlab this will be in one direction, like one dimension, or it will be in this dimension. So it's a single dimensional array. One subscript because it will be holding only one value. So this is called as one subscript. The subscript always starts from 0. Subscript means that is what the index. Index is always started from 0 to 1 less than the maximum size, that is n minus 1 value. Till n minus 1 value it will take. Then example for representation, we want to represent the set of 5 numbers, say 35, 40, 20, 57 and 19 by array variables numbers, and then we may declare the variable number as follows. How we can create the array? What is the syntax? First we should have a data type, right? So what values I am storing? I am storing the integer value. So the data type will be of the type integer. Next, what I should have? I should have a name for the array. array name. Since we are storing the number, they have given the name as number. Then what we have, the size of the array. How many elements I am storing of the type integer? I am storing 5 elements. As they have given 5 numbers I am storing, so the size will be 5. The value can be assigned as follows. Now we have created one memory location, say array number with 5 values, that is index starting with 0, 1, 2, 3 and 4. We have created using this statement. Now we have to put the values for each of the block or each of the element. The value can be assigned as follows. Number of 0. Number is what? Number is a name of array, and at the 0th position I am putting what value? Is equal to 35. Similarly, here number of 1, at the number is an array name, at the position 1 I am inserting the value as 40. That will be 35 and 40. Next, which value is supposed to insert at the location 2 or index value 2? We have to insert the value 20. At the index value 3, they are inserting the value 57. And at the index value 4, we are inserting the value 19. Okay, this how we can declare array and we can assign the value of array. There is another way of assigning the value of array. Instead of doing this, int num of 5 is equal to, directly I can give the value as 35, 40, 20, 57 and 19. So it is a linear array, right? So it will take as a position of 0, 1, 2, 3 and 4. For the position it will take. Okay, clear? This way also we can declare, and this way. This is a very tedious job to do. So usual practice is to declare the array in the second method. Next we will moving on to the declaration of one-dimensional array. How we can declare one-dimensional array? Must be declared before they are used. Before they are used, we must say the compiler that I am using the array of this data type, and space, we should allocate the space in the memory as we have done just in the previous slide. First declare, allocate the memory. Once memory is allocated, give the value for that memory location. So syntax of one-dimensional array, that is data type, name of the array and size of the array, what you are supposed to give. Okay. Then moving on to the two-dimensional array. In two-dimensional array, we have two subscript. As in one-dimensional array, we have one subscript. Two-dimensional array, say if the A is an array name, it will be having two subscripts like this. It is used to represent a table. How matrix will be represented? Like this, right? Number of rows and number of columns will be there in the matrix. This particular first value will give you the number of rows and second value will give you the number of columns. Is generally referred as a matrix of the rows and columns. Then it is also called as two subscript variable. As we are using the two subscript, how we can declare the two-dimensional array? Same method. We have to specify the data type, which data we are going to store in the array. So if it is an integer, give as an int. Then name of the array, say A is a name of my array. What is a row size? I want 3 rows and 2 columns. Okay, this is row size, this is column size. How this will be displayed? This will be displayed like this. We have 3 rows and 2 columns. Okay, you can store 3 values in the row and 2 values in the column. That's what the declaration of two-dimensional array. Next, points to be noted while dealing with the two-dimensional array. The first one is number of sets of initial value must be equal to the number of rows in the array. If I am declaring array A is equal to 3 of 2, then how many values should be there? The multiplied value, what we get, 3 into 2. What is the multiplication? The value is 6. So here I am supposed to have a 6 elements in that. So that is what it's saying, and it will give one-to-one mapping is preserved. Means one element, 1, 2, 3, 4, 5 and 6. One element will be given with the one place, one-to-one mapping. Say let's represent that in the form of array matrix 3 by 2. 3 rows, 1, 2, 3, 4 and 5, 6. This is a matrix representation. 3 rows and 2 columns, right? If the number of initial value in the each initialization set is less than the number of corresponding rows in the element, then all the elements of that row will automatically become 0. If I take the value A of 2, 2, then giving only 1, 2 and 3. What happens here? It will be given with the value 2, 2, 2 rows and 2 columns, right? This will be given with the value because the data is insufficient here. We are supposed to enter 4 elements, right? Because we have only 3 values, we are supposed to get remaining value will be filled with 0. That is what they meant, assigned with the value 0. If the number of initial value in the each initialization is exceeds the number of corresponding value, then it will throw an error. Here you can take an example, int ABC. ABC is the name of the array, int is a data type for the array. Then how many rows? 2 rows and 3 columns are there. 2 into 3, 5. So how it will be represented? Initially 2 rows, 1, 2, 5, 3 columns, then 6 and 7. Remaining will be assigned with the 0. If in place of this 7 I have 8, 9 and so on, right? What happens in that case? It will give you an error because when I am storing it in the form of rows and columns, 1, 2, 5, 6, 7, 8 will be there, where 9 will go. So we cannot store 9. So at that time it will show a compilation error. Okay, this is very important points when we are dealing with the two-dimensional array. Then how do we process the two-dimensional array? Two-dimensional array is generally called as a matrix. Therefore, the kind of operations that can be performed on the matrix using two-dimensional array. We can process the two-dimensional array, or we can use a two-dimensional array in the matrix operations for reading and printing the element of the matrix, finding and subtracting the correspondence elements of two matrix, multiplication of matrix, and searching and sorting elements in the matrix. These are some of the operations what we can do using the two-dimensional array on the matrix. Next what we have is multiple dimensional array. Here we are going to use a subscript more than 2. So what we are doing, we are using a more than 2 subscript. Using a 3 subscript is called as three-dimensional array. The programmer will fill within each pair of the braces the number of the elements to be processed. How many numbers we have to represent within the braces. This is about the multi-dimensional array, or we can say three-dimensional array. It is very complicated to handle the multi-dimensional array. So we avoid the multi-dimensional array. We stick into the one-dimensional and two-dimensional arrays. Next, operations array. What all the operations we have on the data structure? All operations holds good with the operation on array. What all the operation we had on the data structure? Traversal, insertion, deletion, searching, sorting and merging. These all operations that holds good with the array also. What is traversal? Visiting every element of an array is called as traversing and printing that as an output. Then insertion. Insertion is nothing but inserting a value into the particular location of the array. You can insert at the beginning, you can insert at the end of the array, or you can insert on particular index value where do we want. Then deletion. Deletion is again when we are deleting the value of the array. If I have taken a 5 array, I have deleted 5 elements in the array and I am deleting one element, the value of the array, the structure of the array will be of the 4 elements. So that can be done. And then searching means you can search for the particular index value. You can search for the index value or particular element value within the array. Sorting is arranging the array elements in the ascending order or in the descending order so that the searching process will be easy. Merging means merging two sorted arrays together, like array 1 and array 2 will be sorted and that will be merged to have a merging operation. These are some of the operations what we had in array. Then memory representation of linear array. We can represent the memory in two ways. Whenever we say this is a memory representation, this is how we write the computer memory. Okay. So on. This can be the top-down approach, or it can be the bottom-up approach, or it can be top-down approach. So if I say E of 3 is equal to 1, 2 and 3. So A of 3, as this is an integer value, what is a type of array? It is an integer array. We can represent, consider the initial value of the memory location is 1000. We can represent the memory as 1001, 1002, 1003, so on up to 1004, so on up to many numbers. So when we are dealing with this integer value, will have 4 bytes to represent in the memory. Each block, one value, if you want to store the value 1, it will take 4 bytes, as it is 0, 0, 0, 0, 0, 0, 0, 0, and all the values of first 3 bytes will be zeros and 0, 0, 0, 0, 0, 0, 1. So this is the original value what I am going to store, because if we are saying it is a 4 byte, 1 byte is equal to 8 bits. So to store this particular one value, we have to have 8 into 4 bits. 8 into 4 bits. That's what we are representing here to store the value 1. Or I can represent in one more format of the memory where each block of the memory is of 4 bytes. That is 1000, 1004, 1008, 1012, so on. Right. So here each block will be having 4 bytes each. This is 1 byte, 2 byte, 3 byte and 4 byte. When we are representing the same, here all the values will be become 0, 0, 0, 0, 0, 0, 0. Here the value will be stored as 1. Here the value will be stored as 1. So either the way we can represent the linear array in the memory. This is how the actual memory allocation has been done when we initialize the value for the array. Okay, next what we have is array as an abstract data type. First, we have to understand what is abstract data type. Abstract data type is a combination of the value and then the operation. Already we have discussed that how the value is given to an array or value is given to a data structure, and what all the operations we have on the array or the data structure. By combining those two, we are giving the abstract data type. It is a set of value and a set of operation. What value we are giving for which operation, that is going to describe by abstract data type. The definition of abstract data type only mentions when operations to be performed, but not how these operation has to be taken care. What is the purpose of abstract data type? Just to mention what operation we want. How it is done, it's not my headache. That is what the abstract data type is. It does not specify how data will be organized in the memory and what algorithms they are implementing to solve the particular problem. So it does not worry about anything. Not even how the operation is computing, not even how the data is stored in the memory, or not even which algorithm they are using. Just we have a value, we have operation for this value, execute this operation. That much is what they are doing in the abstract data type. Here that is called as abstract, as name of the data type says, it's give only the required information. The remaining information like which algorithm used, how memory, how the elements are stored in the memory, and how the operation is going to execute, it don't give any of such information because it is not required. Which is required for the value, execute this particular expression or do this operation. That is what it will give you. That's why it is named as abstract. It gives the information which is required. That's it. Next, array as an abstract data type. How array can be an abstract data type? While we are saying array is one data type, obviously abstract data type fits into the array, right? The array is an abstract data type that holds the collection of the element accessed by the index. Whenever we want to access the particular element, that can be done using the index. The elements sorted in the array can be anything from primitive data types such as the integer, more complex type like instance, and then the classes. What we are storing in the array can be a primitive data type. It may be an integer or it may be an classes or the instant of the object or instant of the class, that is object. The element is stored in a given index and they can retrieve later at any point in time. Here we are saying that we can store any data type value in the array, and here we are saying that we can retrieve that value whenever we want by using the specifying the index for which value we are supposed to retrieve. The array has one property that they stores and retrieve the element using the index. Storing of the element and retrieving of the elements or the data is only through index. We don't have any other way to store or retrieve the elements of the array. The array is usually implemented by an array data structure. As array itself, we consider it as a data structure. So array will fall under abstract data type. Okay, so that's all. We are completing the concept of introduction to data structure, and keep in mind what we have discussed. That's all for the session. Thank you.